Picture two similar triangles, one proportionally bigger than the other. This problem is an extended triangle. Side pairs are only different by a scalar. So we're dividing 12 by 2 to get our multiplier known as scalar. Our unknown sides can be found by multiplying our matching pair by its scalar. We can do the same for our last unknown side. Magic. First we get vector prime and then project it to planes normal. Using this formula, the projection equation is just a ratio of two dot products multiplied by a vector. Here it is in code. Take a second. Direction A dot forward gives us our unit vector. By unit, I mean a magnitude of 1. From direction A's position. Demonstrate what is a vector here. This being our world origin, and this being our vector. A vector can be visualized as a line segment with an arrowhead on one end. The starting point of the line segment is the origin or offset from origin. The line is a magnitude, and the arrowhead is the final position in world space where the vector resides. Knowing this, we create a new vector from any point in the plane to vector 1, and then we project it to planes normal. We get a new vector by subtracting direction A to plane. Let's separate these. We have two known sides on little triangle, the projection and the direction A dot forward. On the big triangle, only the projection is known. We can get scalar by getting our large triangle's projection and dividing it by our small triangle's projection. Our point of intersection is calculated by multiplying the direction A dot forward by scalar. The last thing to do is to add our offset, or it'll start at world origin. Nobody wants that. That's better. And that's it. Now you have a raycast without a raycast. Here's the code again, so you don't have to skip to the first part of the video. We are a growing community with X followers. If you got a cleaner way to write this code, feel free to keep it to yourself. Stay tuned to see what I use this code for.